Question 5, we have a particle projected with initial speed u at an angle inverse tan 1 over 2 to the inclined plane. So in here, we call this the angle A. Tan A equals 1 over 2 opposite over adjacent and root 5. So the cos of A is 2 over root 5 and the sine of A is 1 over root 5. And then here we have the angle B. We're told that the plane contains the point of projection makes an angle inverse tan 3 over 4. So we can say that the tan of B is equal to 3 over 4. Put your angle in, opposite over adjacent. So the cos of B is equal to 4 over 5. Sine of B is equal to 3 over 5. My initial vector is going to be u cos A in the I direction plus u sine A in the j direction. So that's going to be u times 2 over root 5, so 2u over root 5 in the I direction plus u sine A, which is just u over root 5 in the j direction. My accelerations are going to be minus g sine B in the I direction and minus g cos B in the j direction, so that's minus 4g over 5, no, minus 3g over 5 and minus 4g over 5. We need the time taken. For the time of flight, s of y is equal to ut plus a half at squared. So it's going to be u over root 5 in the j direction times t. It's going to be plus a half, but it's going to be negative 4g over 5 for acceleration. And the half is in there, a half a by t squared. When is this equal to 0? Factor out your t to get u over root 5 minus 2 will divide into 4 twice. So we have 2 gt squared over 5. Just 2 gt over 5. So my initial t equals 0, or u over root 5 will be equal to 2 gt over 5, so 5u and 2g. So my time of flight is 5u over 2 root 5g. Time is equal to 5u over 2 root 5g. So now I need velocity in the x direction and velocity in the y direction. Velocity in the x direction, u plus at, just keep it in vision, 2u over root 5. U plus at is going to be minus 3g over 5 times t, which is 5u over 2 root 5g. This simplifies to 2u over root 5 minus 5's cancel and the g's cancel, so we get 3u over 2 root 5. So having them both over 2 root 5 will be 4u over 2 root 5 minus 3u over 2 root 5, which is just u over 2 root 5, 2 root 5 for the velocity in the x direction. The velocity in the y direction, u over root 5 first, u over root 5 minus the acceleration times t minus 4g over 5 times time, which is 5u over 2 root 5g. The g's cancel. So I get 20u, no, the 5's cancel. So I get the 2 will divide into the 4, so I get u over root root 5 minus 2u over root 5, which is just equal to minus u over root 5. So the tan of the angle, the angle L, if you want to call it L, is equal to minus, which will become minus the v of y, which is just u over root 5, divided by v of x, which is u over 2 root 5. So turning this fraction upside down and multiplying, we will get tan L equals 2, which is what they were looking for in this question.